Welcome to The Explainer. Today we're going deep inside our own heads to uncover the secret cells that are pulling the strings on our hunger and metabolism. All right, let me ask you something. Who's in charge of regulating your blood sugar? Now, if you're like most people, your mind probably jumps straight to the pancreas, maybe the liver, right? And look, you wouldn't be wrong, but that's only part of the story. The pancreas and the liver, they're like the frontline workers, for sure. But the real command center, the master conductor calling all the shots for our body's entire energy economy, yeah, that's the brain. So to really get what's going on, we have to look beyond just insulin. The brain's role here is, well, it's so much bigger and more complex than we usually think. This whole concept is called brain-centric metabolism. See, your brain isn't just sitting back, passively watching glucose levels go up and down. No way. It's actively orchestrating the whole show. We're talking about everything from that primal urge to find food to that amazing feeling of fullness after a good meal, and even how your body weight is managed over the long haul. Okay, but here's where it gets really interesting. The brain has this critical job, right? But it faces a huge problem. To make all these decisions, it needs live, up-to-the-second intel from the bloodstream. And it's got a major security issue. And this leads us to a central mystery in our own bodies. Because you see, the brain is basically an impenetrable fortress. That protection comes from something called the blood-brain barrier, and you can think of it as the ultimate security system. It's this super selective border of cells that wraps around the brain, acting like the toughest bouncer you've ever met, deciding what gets in and what stays out. Yeah, the brain is definitely not a bustling marketplace with its doors wide open. It's more like a fortified vault. And this barrier is absolutely crucial for keeping out all the nasty stuff, like toxins and pathogens that might be floating around in our blood. So, here's the puzzle. If the brain is the commander-in-chief of our metabolism, but it's totally sealed off from the blood, how in the world does it get the vital information it needs about our energy levels? How does it know what's going on out there? Well, the answer, it turns out, lies with a group of truly remarkable and kind of unknown specialized cells. Think of them as the ultimate biological spies. Or maybe gatekeepers. They're called tanycytes. And believe me, these cells are the key to solving this whole mystery. Okay, so tanycytes are absolutely fascinating. They're positioned in these very specific, strategic spots in the brain where that blood-brain barrier is just a little bit weaker, a bit more porous. And they have these amazing long tails that literally reach out from the blood vessels deep into the brain, making a direct connection to our neurons. So they can essentially taste the blood, check for things like glucose, and then securely pass that message along, right past the main security to the brain's inner circle. All right, so now that we've met these incredible gatekeepers, let's break down exactly how they work. How do they turn a simple chemical signal in your blood into that very real physical feeling of being hungry or totally stuffed? It all happens in this elegant four-step process. So at step 1, you eat a meal and your blood glucose levels change. Step 2, the tanycytes are gatekeepers. They sense this change instantly. Step 3, they shoot a direct signal down those long tails to a really important part of the brain called the arcuate nucleus. And finally, step 4, the neurons in that area release specific hormones that, poof, create the actual feeling of being hungry or full. And really, it boils down to 2 main hormones. If the tanycytes send the signal that, hey, we've got plenty of energy here, the neurons release something called POMC. That's your I'm full hormone. It's the, okay, you can stop eating now signal. But if they sense that energy is low, they trigger a different one called NPY. And that is your hunger hormone. That's the powerful go find food now signal. Okay, so this tiny little conversation happening deep inside our brains, it has huge, and I mean massive, implications for our overall health, especially when it comes to regulating our weight. So what this really means is that managing our body weight isn't just a simple math problem of calories in versus calories out. It's much deeper than that. It's fundamentally controlled by this incredibly delicate balancing act in our brain, all orchestrated by these tanycytes. Their entire job is to keep our energy levels stable for the long haul. You know, understanding this is a total game changer. It shifts the entire focus of metabolic health research. For a long time, we've been looking at the pancreas and gut hormones, but this puts the brain, and specifically these tiny tanycytes, right at the heart of conditions like obesity and type 2 diabetes. And that leaves us with a really powerful final thought. For decades, our approach to obesity has focused on the stomach, on diet. But what if the answer isn't there? What if the next great breakthrough in treating these metabolic diseases lies not in the gut, but deep within the brain by learning how to talk to these hidden gatekeepers? It's a pretty fascinating idea, isn't it?